So on this first question, I give you a high and I give you a low, and that's all you really need to be able to write a cosine equation for what goes through that. So first off, I'm going to say dotted line down the middle is huge because it tells you the amplitude, which allows you to like start. So the amplitude is what goes from here up. So where is that dotted line down the middle? Well, it's between 1 and 10. Averaging 11 divided by 2, 5.5 was key. And then that 5.5 up to 10 is a difference of 4.5. 4.5 plus the 5.5 gives you 10. All right, so that's the amplitude. And this is cosine. And then this is one of the trickier ones. I'm just going to put a b for a placeholder for now. And then it's x minus the x value of the first peak, 2. Okay, and then plus 5.5. The midline goes at the end like that. Now, this b that I avoided for now, I better write an equation for it. You should know these two equations. Do you? Do you know that it's period equals 2 pi over b? Or you could say b equals 2 pi over the period. If you didn't know one of those, you better write them down and memorize them. They're going to come up on the test for sure, probably more than once. Okay, so now this part is b. So which is it? That's b, 2 pi over the period, if I only knew the period. But I do, because from here to here was 6. So a lot of people think the period is 6. It's not 6, it's 12. Okay, because that's only halfway done. You'd have to go all the way over to the next peak over here, which would be double that far. So it's 2 pi over 12. You could reduce that to pi over 6. Any questions on that first equation? Yes? You should always simplify unless you're in the middle of a graph. Because in the middle of a graph and you go like 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, those are better not reduced because you can see the pattern so easy. So here, I know, this is the one that you could reduce. I'm just saying there's a difference there, right? On a graph, I really wouldn't want you to reduce. Any other time, I do want you to reduce. Okay, so that should be really pi over 6. All right. I gave you another one. Let me do that before we get to that sine one there. Here's the other one I put on the board. 4 tan of 3 theta minus pi, and then all of that plus 6. And I asked you for the amplitude. That's an easy one. It's just 4, the number out in front. Then I asked you for the phase shift. And the phase shift is that, but not that. You got to factor it first. Making sure I wrote this correctly. I think I did. And so my phase shift is right. Did you include a direction word? If all you said was pi over 3, you would not get credit. Right pi over 3. Phase shifts are a direction. Directional. Okay? So the next thing is, what is the vertical shift? Well, that's easy. That's the vertical shift. And it's 6 or up 6. These are not directional, so I'd be fine with just saying positive 6. And last but not least is the period. And the period is 2 pi over b, and b is 3, so 2 pi over 3. Wrong. It is not 2 pi over 3, and I know a lot of you have that. You know why? Because the period of tangent isn't 2 pi in the first place. What is the period of tangent? Say it.
Pi.
Pi. The period of tangent is pi. So right here, we needed pi over b. And the b was 3. So pi over 3 is the answer. I thought it was always 2 pi. Well, it is for cosine. This was tangent. Are there any other periods you have to worry about? No. Tangent's the oddball. Sine, cosine, and the secant and cosecant that go with them, they all have a 2 pi period. It's only tangent and cotangent that have a period of pi. All right, I think I would have caught a lot of you on that one. So now, I'd like you to just do a plain old-fashioned graph of sine with a couple changes. I'll pause for a second while you give that one a try. And I'm going to give you one more to work on because people finish at different paces. And I don't have to just sit there if you're waiting. Y equals 3 tangent of 2 theta minus pi. And that's going to look so different than the sine one. Okay, on this first one, sine looks like that to start with. With a 1 there and a negative 1 there. Pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, aka 2 pi. But then this 4 happened. So I multiply by 4 here and here. Then this 2 happened. I'm going to factor it out. 2 comes out, and I got theta minus pi over 2. If you can factor it, you should. And then this 2 here, you don't multiply by everything by 2, you divide everything by 2. So I'm multiplying by 1/2, which does the same trick. And then this is pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. Now, which of those is the same as pi over 2? 2 pi over 4, this spot right here, that's the same as pi over 2, if you simplified it. So you got to move it over 2 marks. These are phase shifts or directional. It's right. And so now I take this spot where I normally would start my sine and I move it over here, and I'm going to make it a dotted line. And it would look like that, like the dotted blue line. It's shifted over 2 marks. Now I can't just leave it like that though. This spot was 4 pi over 4. The next spot will be 5 pi over 4. And the next spot will be 6 pi over 4. And I have to label those. I know that got really messy. Oh, wait. Yeah, I got these labeled already. The 4 and the negative 4 are something to look for. And this 2 means all my denominators had to be multiplied by 2, and they were. And then I moved it over to the right, and I had to label a couple more spots there and there. This last one is 6 pi over 4. Okay, any questions about that one? Then let's do tangent. So I'm going to factor this out right away. 2 theta minus pi over 2, same idea as before. I'm going to move it down to the bottom just so I have more room to work up there. And erase out some work. More room to make the graph. Okay, so now tangent starts with 2 asymptotes here and here. And this is pi over 2, negative pi over 2. And this is important. I don't know if I stressed this enough before, so you tell me. Did you know that right here, where this is halfway between the asymptote and the y-axis, that's where 1 would be. And right here, where it's halfway across again, that'd be where negative 1 would be. Okay, and this spot would be where pi over 4 is, actually negative pi over 4. And this spot is positive pi over 4. Why? Because it's half of pi over 2. Half of pi over 2 makes pi over 4. Okay, so all of that was just to get regular tangent graphed. Now I go through and change this 3, makes me change this to a 3 and a negative 3. It's a negative 3. The negative kind of stuck to the 3 here. I'll clean it up. Negative 3. Okay? And then this 2 here makes me go and multiply everything by 2. No, multiply it by 1/2. So now my numbers are pi over 8 and 2 pi over 8, also known as pi over 4. And negative pi over 8 and negative 2 pi over 8, also known as negative pi over 4. Okay, then the last thing I have to do is the most painful part by far. I got to move it right pi over 2. Well, the good part is I can see where pi over 2 used to be. So I just got to figure out where pi over 2 is now, because I have to move this thing over that far, however pi over 2 is. Well, this is 1 pi over 8. This is 2 pi over 8. Then I'd have to move it another 2 marks would be 3 pi over 8. And then the last mark would be 4 pi over 8. And that is pi over 2. That's how far we have to move it over, is 4 marks. Now that's where the middle of the graph is. The asymptotes would move with it. So this asymptote here has to move over 4 marks. Everything's going to move over 4 marks. So that asymptote would go here, and the other asymptote over here moves over 4 marks, and it ends up right on top of where this asymptote was. So weirdly, because we're moving it over just the right amount, this asymptote just moves over on top of the other asymptote. And now I draw my tangent through there, and I keep my labels of this was 3 pi over 8, 4 pi over 8. This is 5 pi over 8. And this last dotted line here is at 6 pi over 8. All right. I'm going to clean that up and give you a final answer here. And halfway between there, there. Okay, I had lots of requests on doing more with graphing tangents. And then because there was a 3 in the front of it, I'm going to put a 3 here and a negative 3 there. All right, next kind. Secant and cosecant. Haven't graphed any of those in a while. Let's get cosecant. But you'd never have it as easy as just graph cosecant. So let's make it 8 cosecant of 7 theta. Start by graphing sine. Why? Because cosecant is 1 over sine. And wherever sine hits 0, that'll create asymptotes. I'll pause for a sec while we give that one a try. How would I start graphing? All right. Are you sure?
Sine.
Okay.
I'm getting mixed up.
All right. Did you actually do sine on your paper? Because if you didn't, I'll move to somebody else.
Yeah, I did.
Oh, good. Okay. So then it was 1 and -1, and this is 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Okay, now what?
Then you change the ones to 8s because the integer's 8.
Yep, because of this 8, this becomes 8, and this becomes 8. Keep going.
Then you put asymptotes where sine equals 0.
Wherever sine hits 0, which is there, and there, there's asymptotes. Okay, now what?
And then you like put the parabolas inside of the asymptotes.
Like this, I hope you mean?
Yeah.
Okay. And we're not quite done. We're really close, though.
Then you divide all of the x-axis values by 7.
Because of this 7 here, you wouldn't multiply by 7 because it's on the inside. You multiply by 1/7. And this is pi over 14. And once you know the first one, you know the rest. 2 pi over 14, 3 pi over 14, 4 pi over 14, etc. Okay. I'm not too worried about cosecant and secant. I'm not too worried about sine and cosine, but I'm kind of worried about tangent. So let's just do one thing more about tangent. One of the hardest things is to figure out where the asymptotes are. Because seriously, if I told you there was asymptotes here and here, most of you guys could do well, and then it just goes like this. The actual graphing the thing is easy. It's the asymptotes. Okay? So where are the asymptotes supposed to be? Well, I'd like you to figure out where are the asymptotes on this one. All 3 of them that I have on the board. If this is tangent, where are those asymptotes supposed to be? I know the first 2 are pretty easy, but where's that third one? Okay, you should have known this one was pi over 2, and this one's negative pi over 2. But then there's a tendency to think of all the marks as pi over 2's, and therefore this should be like 2 pi over 2. It's 3 pi over 2. Why? Think of it this way. The little marks are actually pi over 4's. So this is 2 pi over 4, 3 pi over 4, 4 pi over 4. I just did that wrong. I'm going to double check that. 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay, I'm making my brain hurt. I feel like this is supposed to be pi over 2 here, and then add another 1 whole pi, and make it 3 pi over 2 here. But why is it not working when I do it in pi over 4's? Isn't that where 4 pi over 4 would be, which would be pi? Okay. This is one of those I'm being really tense moments. How about this? Let's make sure that you guys have the same thing as me. Do you guys agree that this is 3 pi over 2? Okay. But then help me understand why. Okay, is this right here, is this pi over 4?
Yeah, your spacing is just a little bit off, so there's not much space for pi in the middle of pi over 2 and pi over 2.
Okay.
And then there would be pi over 4s in between pi over 2 and pi, and in between pi and pi over 2.
And I know all the things you're saying are right, but wouldn't this be 2 pi over 4? Okay. Oh, okay. There's actually Now I'm seeing it. There's actually 3 more marks in there because it goes through the middle of this. Okay, now I'm seeing it.
Because the central line is technically a mark on the other.
Yeah, I was acting like there was only a mark in the middle. There's actually a middle, and then there's these extra ones here. 3 pi over 4, 4 pi over 4, 5 pi over 4, and 6 pi over 4, which is the same as 3 pi over 2. Okay, there. Whew. So that's how you get the asymptotes for tangent. The easy ones are the first 2 that you draw. Okay, last but not least, for cotangent of 3 theta. Hint, cotangent is not have the same asymptotes to start with. The asymptotes are in different places on cotangent. If you're struggling with where to put them, remember that cotangent is cosine over sine. That's what cotangent really is. So that'll help you figure out where the asymptotes have to be. Pause for a second, give you a chance to try that one. Okay, so cotangent's asymptotes start here and here. And since it has a period of pi also, this is pi and this is 0. Then cotangent runs right up the middle. It has asymptotes here, or not asymptotes, sorry, marks there and there. So this is pi over 2 would be right in the middle, also known as 2 pi over 4. This is pi over 4, 2 pi, 3 pi over 4, and 4 pi over 4. Totally be fine with you saying it that way. Okay, then this 4 here takes the mark that would be here, would have been a 1 and a -1, and it changes those to a 4 and a -4. And then this 3 here, you don't multiply everything by 3, you multiply everything by 1/3, which puts a 3 on the bottom of all of them. So pi over 12, 2 pi over 12, 3 pi over 12, and 4 pi over 12 right there. Make sense? Yes?
Since it's cotangent, wouldn't the line be like flipped?
Oh, darn, you've got me. I did a tangent line. It should be like that. I imagine most of you did that, and you probably didn't even just see that I was doing it wrong, but it's easy to make that mistake, boy. Yeah, that's how cotangent is supposed to look. But if there was a negative in front, do you get it would go back to what I just had a second ago? So that what I just graphed was technically negative cotangent. Okay, that covers a lot. If I was going to give you one of these kind of problems where you're supposed to find the equation and you'd need a high and a low, right? What if I gave you numbers? 2, 10, 3, 11, 4, 12, 5, 11, 6, 10, 7, 11, 8, 12. Do you see the wave happening? I'd like you to figure out what's here and what's there. From your data, X and Y data, would you agree this is the first peak? You should have said that was 4, 12. And then the next low spot after that would have been 6, 10. And then you could go off and running and find the line down the middle and figure out the amplitude and all that good stuff. Make sense? Okay. So there's a review worksheet. I almost never collect homework. But the key word there is almost. It is assigned. You need to do it. I will allow you to skip one. I'm not going to say which one to skip because this is more about saving you time than it is like, oh, there's a problem with repetition. Just do all of them except one. Drop it in the Dropbox. It'll be the best thing you could do to study tonight anyways. And I don't feel like it's going to be that hard. So it's a double whammy. You'll ensure success on tomorrow's test and you'll get credit for it in your homework. So do it, turn it in, and that's all I got for you for the video for today.